In this lesson, we will combine horizontal shift, vertical shift, reflections, and stretch vectors into one equation called vertex form of the parabola. We'll also draw a graph of parabola in relation to the base graph f of x is equal to x squared, and we'll discuss some of the elements of the graph like vertex, axis of parabola, maximum and minimum values. Let's get started with the given equation. Here the given equation is f of x equal to 2 times x minus 3 square plus 4. We need to find out what would be the vertex. If we compare it with the standard form, comparing with f of x equal to a into x minus h square plus k, for which we know that the vertex is hk. So if we align both of these equations, then this 3 has been replaced with h, or h has been replaced with 3 for the current equation. K has been replaced with 4 and a has been replaced with 2, which suggests that vertex is equal to, so vertex is equal to 3 and 4. Watch for the negative sign and the positive sign outside. So here it should be negative sign and it should be a positive sign right here. If you see the other sign otherwise, you can flip those signs. So vertex in current case is 3, 4, and for drawing the graph of this parabola, vertex is very important. So let's find out where the vertex is. On the current graph grid here, 3, 4, 1, 2, 3 and 1, 2, 3, 4. This is where the vertex is. Vertex is equal to 3, 4, because we are going to start from the base graph and then we will apply horizontal shift of 3 units toward right, vertical shift of 4 units toward positive y-axis, and then we'll go from there. So graph of given equation is same as f of x equal to x squared. We just need to apply horizontal shift. This was number 1. Horizontal shift is how much? 3 units toward right. 3 units to right. Whenever there is a negative sign inside the square term, we apply the shift toward right, and whenever there is a positive sign, we apply the shift toward left. Here, because it's negative sign, so we apply the shift toward right. Number 2, vertical shift. K equal to 4 units toward to upward. upward. All right. So we also applied 4 units of shift upward, and here you can see that the base graph would start from here, from the origin, and the vertex would be at 0, 0. But we have applied the shift 3 units toward right and 4 units toward upward, and that's how we got the vertex at 0.34. And now we are going to apply the third transformation, which is vertical stretch. So number 3, A is equal to 2, which is greater than 0. So the graph opens upward. So there is no reflection. There is no reflection. No reflection. And we apply vertical stretch. And there is a very interesting method to draw the graph and apply the vertical stretch. We start with the numbers 1, 3, 5, 7. Start with numbers. Start with numbers 1, 3, 5, 7, and multiply it with the value of A, whatever is A here. A is 2. If A is 2, then multiply these numbers with 2, and 1, 3, 5, 7. If we multiply 2 with each of these numbers, this will become 1 times 2 will become 2, 2 times 3 will become 6, 10, and 14. And now we go like this. We start from the vertex and we go 1 unit toward right and 2 units upward. So 1 right and 2 up. We end up here. And then 1 unit right and 6 units upward. So 1 unit right and 1, 2, 3, 4, 5, and 6 units upward right here. And then 1 unit right and 10 units upward. So 1 unit right and 1, 2, 3, 4, 5. We are not going to get there, but that's what our graph should look like. And similarly, we go 1 unit left and apply and go 2 units up. We end up here. And then 1 unit left and 6 units up. So 1 this way and 1, 2, 3, 4, 5, and 6. We are here. We don't have enough space to go any further, but we can use arrows. So here we are going to smoothly draw the graph through these points, and here is our graph passing through these points, and we can use arrows to indicate that there are more values which can be written there. So this is the graph of y is equal to, or f of x equal to 2 times x minus 3 square plus 4. This is we did by applying the horizontal shift of 3 units toward right, 4 units of vertical shift upward, and 2 units of vertical stretch. And this and the original base graph we can always find out, but we don't need to write that as it is not required. So this is for drawing the graph of the given quadratic function, and now we need to answer those questions which were asked. First was the vertex. We already answered that. The vertex is equal to 3, 4. And number 2, axis of symmetry. Axis of symmetry. Axis of symmetry are the square term equal to 0. So what was the square term in f of x equal to 2 into x minus 3 whole square plus 4. This is the square term. If we put it equal to 0, that will give us axis of symmetry. So this would be like 2 times x minus 3 square equal to 0. As 2 is not equal to 0, as 2 is not equal to 0, this means x minus 3 square is equal to 0, which can be 0 only if x minus 3 is equal to 0. And this gives us x equal to 3 as axis of symmetry. As axis of symmetry. And since the graph opens upward, third, since the graph opens upward, so there is no maximum point. So there is no maximum point, and minimum point is the only possibility. So minimum point. So minimum is equal to y coordinate of vertex, and this is equal to 4. So this is what we can say about the minimum. And still there are other properties and other elements of the graph which we have discussed in previous lessons, and if we want to find out those, we can still find out, like intercepts. So fourth, let's find out intercepts. And for first we are going to find out x-intercepts. For x-intercepts, we are going to place f of x is equal to 0. For x-intercept, put f of x or y equal to 0. This gives us 2 times x minus 3 whole square plus 4 equal to 0. So if this is equal to 0, then 2 times x minus 3 square is equal to minus 4, which means x minus 3 whole square is equal to minus 4 over 2, means x minus 3 whole square is equal to minus 2, which is impossible because square of every real number is always positive. But here x minus 3 whole square is equal to negative number, which is impossible, which is not possible because there is no real number. For every real number, for every real number, square is always positive. Square is always positive, or minimum it can be 0. Can be 0. So but here in this case the square is equal to -2, so there is no x-intercept. So no x-intercept. X-intercept. And for y-intercept, for y-intercept, we have x equal to 0. Put x equal to 0. This gives us f of x equal to 2 times 0 minus 3 square plus 4. So this is whatever this value is, 2 times 9 plus 4. So this will be 18 plus 4. 18 plus 4, this is equal to 22. So the y-intercept, hence y-intercept is equal to 0, 22. So this is it, and we can also find out about focal length. Focal length is equal to 1 by 4 of the coefficient of x square. Coefficient of x square, which is a. So what was the value of a here? A was 2. Therefore, the focal length is equal to 1 by 2. And if we want to find out the directrix, the directrix would be definitely, it will be below the graph, because on the graph, if you take a look, if 1 by 2 is the focus, that is right here, if that is f 0 1 by 2 is the focus, then the directrix will be just below the graph that will be going through this. So this will be equation of the directrix. We usually call it dtx, and this is y coordinate of vertex minus focal length. So this is equal to equation of directrix, equation of directrix is y equal to y coordinate of vertex minus focal length. So this is equal to 4 minus 1 by 2. So if that is the case, then this would be equal to 8 minus 1. So this would be 7 by 2. Y is equal to this. And if we want to find out equation of lattice rectum, equation of lattice rectum, that is similar to this, but this time it's going to be positive. So y equal to 4 plus 1 by 2, and that would be equal to 9 by 2. This is equation of lattice rectum. Length of lattice rectum length of lattice rectum is equal to 4 times focal length. This is equal to 4 times 1 by 2. This is equal to 2. These are all properties of parabola, and we still haven't discussed properties like tangents to parabola and asymptotes, and there are some other properties which you are going to learn a little later. Even some of the properties are not very relevant to your course of study, but those are very helpful for the people, those who want to learn it in detail. See you in the next lesson.